going to slowly move into convolution. So for that, I am going to open one code which is available with graphics. It will be very, very helpful to understand this convolution. So I think this code should be able to understand what is convolution. Okay, so I think you are able to see the page, right? So whatever basics I have written the live code that is over. Now we are going to move into convolution. How to perform convolution using MATLAB, using the, this is the convolution formula. Convolution is actually shifting, multiplication, integrating, adding. Shifting, multiplication, and adding is going to be convolution. See, now I am going to have a rectangular signal and the triangular signal, and I am going to convolve both. Okay, so it is, they see, closely observe this one. It is going to be a live script, so you can feel the convolution which is going to happen in a graphical way now. See here, the program is running. You're able to see what is the graphical thing happening. Is beautifully explaining the convolution. Convolution is, I'm going to keep one signal fixed. I'm going to move the other signal. And in that moving part, if I have any overlapping region, I'll be multiplying, adding, and integrating. Okay, so see here, I have just used rectangular and triangular. Maybe see, I'll use when you convolve two rectangular pulse, what is the answer? Can anybody say? When you convolve two rectangular signals, what is the answer you should get? When you convolve two rectangular signals, what answer you should get? You should get a triangular signal. If both the rectangular signals are looking identical. See here, the rectangular signal is having a period of 1. See here, minus 0.5 to plus 0.5. Triangular signal is also having a period of 1. Now see, I am going to use two rectangular signals of same amplitude. And if I run this, answer I told you, the answer should be a triangular signal. So we will see if we are getting a triangular signal here. See, the rectangular signal is slowly moving. See how the animation is perfectly done in MATLAB. So what is written in theory is becoming true. As the rectangle completely moves away from this original rectangle, the signal becomes 0. So the overlapping is available only from -1 to 1. And you see here, this rectangle has a period of 1. This rectangle has a period of 1. This triangle has a period of 2. This addition of the total period of this one and this one. Is that clear? So I told you, when you convolve rectangle and rectangle, the answer is a triangular signal. Now we have 4 possibilities here, right? Rectangle, 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 triangle, triangle, triangle. So we have seen one. The next one is rectangle, triangle. So if I convolve rectangle and triangle of equal amplitude, I should get a Gaussian pulse. We will see whether we are getting a Gaussian signal here. See, the triangle is slowly moving. You know how a Gaussian pulse will look like. It is a symmetrical curve, a bell-shaped curve. How beautiful you see. Oh, it is generating a Gaussian, perfect Gaussian wave. Time is also, see, -1 to 1, it is 2. 1 for this rectangle, 1 for this triangle. And now both are triangle. Both are triangle means you will get a raised cosine pulse, I hope. You'll see. It will be looking like Gaussian pulse, but it will be looking like a cosine signal, raised cosine signal. Perfect.